Hello, everyone, and welcome to Deep Engineering Live Interview Series. I am Saqib Jan, Editor in Chief of Deep Engineering. Today, we are talking about the future of software development. We will talk about AI agents, token efficiency, and what AI native engineering asks of the people building through it. Agents are moving from demo to deployment. The tooling around them is production ready, and engineers are making real decisions right now about how agents fit into their stack and what they're allowed to do and what they cost to run. Few people are better placed to talk through those decisions than today's guest. Rory Preddy has spent his career in developer relations at Microsoft. He started out as started out in audience development, served as senior cloud advocate, and now works as a principal AI advocate and also at the same time developer relations. What runs through all of it is that he genuinely likes helping people, and he spends his weeks doing exactly that with engineers working through the ship. He has also brought a presentation with him today on cost optimization for AI workloads, including how agentic loops drive costs at scale. So we will get into that as well. I'll bring Rory on stage. Rory, welcome to Deep Engineering. Great to have you here.
It's incredible to be here. I have to tell you, I'm a big fan of Pact Publishing. I've read many of your books. I haven't published a book yet, and that's on the cards there. It's on my list of to do things though. So big fan and really excited to be here.
Awesome. Well, thank you so much, Rory. I would like to give you the floor if you could tell a bit more about yourself that I actually introduced you, and also tell us the work you are doing at Microsoft. And you also have some courses that you have published on GitHub. Plus, you're going to also take us through your presentation today. So please shed some light on what we are going to do today.
Okay, so I've been in IT for 27 years, and 23 years of that have been a programmer. I started as a Java developer, and then I moved to Microsoft about 7 years, 8 months. I don't know why I'm counting the months though, but 7 years and 8 months ago. And I went to throw parties for them. I know that sounds a little bit weird though, but I was what they called a developer audience marketing manager. And what that meant is that I could get some money and I could throw parties, and then I could show and give developers a safe place to be creative. We rolled out the data centers in South Africa. And then after that, I started being able to see the world, how big the world was. I got exposure to the world. And I started to say to myself, wow, Microsoft has so many different opportunities. I contacted Jeff Sandquist at the time. He was head of developer relations. And I said to him, I have stories to tell developers across the world. I want to do that with your help. I've been a developer advocate for 5.5 years. And of course, that was a cloud advocacy. And the cloud has matured now, and the hype has kind of like dwindled a little bit. And in developer relations, we always kind of follow where the excitement is. And the excitement right now is in AI. And I decided to make the move to go to AI advocacy, and it's been a wild ride. And only recently, instead of saying to people, buy AI, I said, wait, hold on 1 second, take a step back. I want you to just just take a step back and say, let's not spend too much, really, okay? I understand that you're all very excited, but I don't think you need to spend, and I think I've just lost the screen against here. I don't think you're ready for AI if you're not going to actually understand how it works though. Let's go here, screen share is now visible, there we go. And now we can go from beginning, and there we go, okay. So that's also what I wanted to show you today, is that you can use AI native, you can use agents, but you need to take a step back and say, yeah, I don't have enough money to do this if I don't know what I'm doing. So I've got some nice demos to show you today about patterns, about what is AI, because I don't think a lot of people even understand what AI is though. What is caching, what is compression, or what makes a prompt, how do you actually do that safely? Then you can reach out to me on my LinkedIn profile and Twitter, and I'm really excited to have this interview today.
Awesome. Awesome. Thank you so much, Rory, for joining us. What we will do first is we will let you take us through the presentation. And at the end of it, I'll come on stage, I'll ask you some questions, and people from audience can also ask some questions. So with you, I'll give you the floor. Thank you so much, Rory, for joining us today. Please continue and start your presentation.
Now, no one has seen this presentation, so it is a kind of like a really exciting thing for me to do with you, and it's a premiere for that though. So I'm going to go through that, and we've got some nice demos that we can run through also though. So first of all, take a step back. I did mention to you, we're in a bit of a trouble right now because everyone's like, oh, I want to be token maxing. I want to go spend that money. I want to make sure that, you know, like I can do the maximum of that. And then we get Rory, who actually I'm the host of and the creator of LangChain for J for Beginners, which also says, don't worry about, you know, spending about that and everything. Just go in and use my training. And I'm going to give you the link for LangChain for J. And I had to take a step back because we're seeing bills of $500 million for AI spend. This is an actual bill, and it's the image isn't really real though. But one of the consultants, I think it was Accenture, who actually said, you know, Claude, they got a bill for $500 million for one of their customers, and took a step back and I said, does everyone know what AI is though? Because we even created and we're one of the founding members for the Linux Foundation, and there is a part of the Linux Foundation called the Token Economics Foundation for cost management. And in that, they define exactly what tokens are and how you can better understand the costing and put in protection mechanisms for that. So I want to take a step back. I'm going to teach you about tokens. So the first thing is I need to tell you that I love AI. It's 4 tokens. And depending on your costing model, it can cost differently for each model though. Now, you've got choices when you do AI. You've got the model choice. You might use GPT or Claude or even Grok if you're feeling brave. And then you've got your prompt structure. You need to actually go in and make sure you're prompting it right. Then you've got your cache key stability. What? No, don't worry. I'm going to tell you about that. And then you've got your output limits that you can set also. And all of those depend and make the cost different based on what you're going to do. Now, it's very confusing. This is the live pricing that we have here, prices.azure.com for the API retail prices. And you look at it and you go, okay, what is 5.5 shortcode batch implementation G1, 1 million tokens in Poland Central? And it's got a cache key of a pricing that is different there, retail price, unit price, currency code. So take a step back. Okay, let's all breathe. It's not confusing at all. I'm going to show you how to do that now. The first thing I need to tell you about is caching. So if you go there, okay, cool, tell me a joke. And you go, okay, that prompt that you're sending in there, tell me a joke. Now you ask it again, tell me a joke. Are you going to be charged for the second time that you say, tell me a joke? No, you're not going to be charged for that. Or if you are, it's going to be a very minimal charge though, because what you're doing, the AI is going to say, oh, I've already sent you this information through back to you. I don't need to do that. But what happens if you go, I'm an insurance company, please send the millions of insurance customers that we have their latest statement. So you get, I'm an insurance company, this is your latest statement, and then right at the bottom, you get a dollar amount. You don't pay for that little blurb, that's called the stable prefix of I'm an insurance company, this is your statement, but you do charge for the tail. And that's the tiny little bit of the dollar amount there, and that's the cache key. Caching can take your huge bill that you have there, and it can just throw it out the window, because you're not going to pay for that huge sum. You're going to pay for just calling it a few cents rather than dollars. And how it does that, it hits it there and says, did they say, here's an insurance company, here's my statement. Is it in the cache? No. Okay, cool. Then bill at the standard rate. If not, and it can find the cache hit though, no, you've already sent it there. Rather reuse it there and send it back for a cheaper cached input, which you basically don't pay for it. So that's caching. The first thing I want to tell you about that, and you can see it's not really that complicated. Just think ahead with the prompt structure. I want to do the prefix, and then I want to do the key of that, and you'll save so much money. The next thing is to compact it. So every time you talk to an AI, it remembers what your conversation is. But many times you're going to want to actually compact your conversation. And you can see there, I've got it there. I've got two compaction queries. Compact the submitted working notes into concise, durable context, and then also a caveman one to actually see, wait, can I speak like a caveman? Is caveman speak actually less? Answer like a caveman to say output tokens. And you can see there that without the, let's go into here, without the cache with the compaction, you're just going to start more and more with your conversation, paying more and more and more and more. But if you go in and you compact it, you're going to go compact it there. Okay, a little bit more, compact it there, and then a little bit more, and then compact it there. So it's a huge cost savings around token efficiency. We've looked at caching and also compaction. Those are the two main fundamental mechanisms that you can actually save with costs, though. So I had to do a demo to show you this. So I use my GitHub Copilot. I work for GitHub. We're one of the largest developer in houses. We've got 180 million people on GitHub. We've got more than tens of millions of GitHub Copilot licenses here. And then I said to myself, but by showing them the demo of how to use AI agents, I need to also show them how I built it. So using GitHub Copilot, I said, look, everyone's vibe coding right now, but you need to vibe code correctly because you also want to save some money. You want to make sure you have a dev container.json so everyone can use it. It doesn't just work on my PC, it works on other people's PCs also. You have a Copilot instructions file so the agent doesn't actually act like this man here. He's just vibe coding blind at the keyboard. And you also want to use an agent profile if you're going to use agents. And what agent profiles do is they drop MCP tools. And what is an MCP tool? It just means if you've got like a calculator or if you've got a custom tool though, and you don't actually need to use it, you don't send the JSON through and from. Remember what I said to you, if you're going to use a prompt, you want to be optimized for that prompt though. You want to scope your sessions every time you talk to it, you understand what you're sending there. You keep your prompts precise and short. And then you also want to use the smallest model that fits. We have maybe 20,000 models now on Azure Foundry. You want to use the right model, and we've just released GPT 5.6. I'm going to show you a demo now about that, though. You want to use direct completions if you can. You don't want to just say to the agent, go wild and just spend the money there. You want to watch your inputs, outputs, not just your inputs here. And you want to use design patterns when it comes to how you manage the cost. And I've got a nice little example of the design patterns, and we'll go through the demo also with that though. The first one I want to introduce you to is the router. And these are the agents that you're going to call, but you're going to have an agent here, and I've got the Luna classifier. And what Luna is, the GPT 5.6, it's a very small little agent that you can run. It's the smallest one that you can do, and it's going to go, okay, cool. Instead of me sending it straight to Sol, GPT 5.6 Sol, I'm going to say, classify this as, wait a second, I need a big boy agent or I need a smaller agent. And that's the router pattern. Then you want to triage, and triage basically says escalate only when complexity earns it though. Very similar to the router, but it says this is a complex prompt. I want to prove quantum gravity. Okay, maybe the small model doesn't know how to prove quantum gravity. I'm going to send it through to Sol, which is the really big one. Really big, expensive though. And well, there we have context compression. And remember what I said there, you want to do compression here. So, oh, it just dropped again. I think we're having a little bit of, or let's go into there again. We're having some, let's go from current slide. There we go. I think it drops it occasionally there, but no worries about that. As a professional, I know what I'm doing. I'm in charge, and also I can recover. You've got context compression here, and you can see there that we've got the long context. Luna's going to compress it cheap there, compact the context, and then Sol is going to do the reasoning. The same with RAG. You're going to go look at the retrieve evidence instead of sending the corpus, which is you've got your document, you're going to chunk it up. and you're going to just retrieve a little bit of your document instead of going, hey, here's my insurance quote here. I want to retrieve the entire thing. No, you just need to know your dollar amount. Your tool use here, you want to go, wait, and remember what I said about the MCP tools? You're going to find the exact tool that you want to use there. Make sure that you don't use the incorrect tool. Step back planning is Luna is going to say, maybe I should plan. You're going to send me a prompt. Maybe the agent needs some help in how I'm going to plan this, though. And then the Sol will execute there. And then caching, we touched on that a little bit there. If you're going to miss the cache, though, you don't want to actually really miss the cache if you're going to hit a cache without knowing what you're going to fill the cache first, though. Make sure that if you go, please give me my insurance document, that you actually don't pay for that there. And then last one is you're going to batch it there. You're going to parallel map there. And then you're going to say, I'm going to use the right worker there and send it through there. And these are design patterns, common design patterns that we're advocating. And it's very new, though, because we've just broken up 5.6 into Luna, Terra, and Sol and Microsoft Foundry here. Okay, cool. I don't really know, Rory, if patterns is the best. I want you to give me the easiest solution. There is an easier solution. There's just two commands you're going to do. It's chronicle and limits. And what chronicle does, it takes what have you done in your with all of your agents, the CLI, the Copilot app, VS Code, JetBrains IDEs, Copilot SDK. You just go /chronicle, and it's going to go and say everything you've done. Are you doing it the correct way? And it will say, you can see there, chronicle cost tips there, and it's going to go back and it's going to search your local database, your SQLite database, and it's going to say, whoa, here's the data showing how you can cut spends here. You're not compacting long sessions. Remember what I said to you? I wasn't compacting long sessions. I also fall into bad practices. And then we also, once you know that you're not compacting your sessions, maybe you want to actually just limit it to make sure that you're not spending too much money. We have a very nice /limits there that says, you have exceeded your limit. Please, with /limits, do you want to add AI credits or do you want to carry on spending? So it's just awareness. What are you doing? How do you create that awareness? So that's the demo that I want to show you. You can access it on github.com/RoryP /token design patterns, or you can snap that token, that QR code. Now, I also wanted to show you in the demo. Let's go into here. Let's go into aka.ms costs. I'm going to go a little bit later in the demo here. And then I also want to show you LangChain for J for beginners, which is the training that I did, though. So that's everything. So let's go into token design patterns. And I actually have the demo running right now. So let's go into here. And I want to go into here. And I'm going to show you here. I'm going to go to aka.ms. Let's go to CA, and we want to go into there. And we want to go into, let's try that. Okay, let's go into, I don't have the actual URL directly on me, and let's go into here and I will show you that. But you can click through here with the token design patterns while this is loading here. We're 22 minutes into we're already into the demo. Into the demo here, let's go token flow here. Let's go back there, forward. Let's go there. Token flow dev, and yeah, that's what I want. And then we're going to get the URL. Now, all of this is actually hosted on Azure, and you can play around with it while we were actually going through that. I'm going to show you the actual token flow. And then I can also show you, let's go into here, let's go into the token the demo here. I can also show you into the token apps here, the instant model. So let's go in while this is loading here. Let's go aka.ms/costs. Yeah, let's do that run. There we go. Here's the token flow. So this is something really binged me, but okay, so let's go. You can see here's the router, and then this is what the demo does here. So we've got the, let's make that a little bit bigger here. We've got the root, and I'm going to show you the one there, knowledge, code, and architecture. And I've got the small model, medium model, and large model here. And it was pretty simple for me to do this. And I'm using LangChain for J agentic. And inside that, it's the agentic models. Let's minimize there. And I can just go here. Let's go run router. How does my Java stream return an empty list after I add a filter? And I can run the router here. And what it's going to do, you can see there, it's going to go, I want to use the medium model there. And then I got my answer that I've got there though. So that's the first demo I want to show you. And you can go and access that code there. And you can see there, I've got my model baseline. I've got my how many times I called the model, overall the projected savings, and I can run this. And then once I do that, I can look at triage, context compression, retrieval, tool use, step back planning, caching, and batching. The next demo I want to show you is the token efficiency. And this is a kind of a very basic model here. And in that, I've got the live Azure core rates here. And you can see there, I've got the cache rate and also the cached inputs and also the inputs. But watch the difference when I do the cache inputs here, the prompt cache demo. And you can see there, that's the cache that I load there, 120 stable selections that is going to do. And I saved 99% just by warming the cache and then getting there. Then I've got the compaction there, which is how much can I compact here? And I've got the compaction before, and I've got 409 tokens, and that prompt that I showed you, now it's 233 tokens. I send that back, and I can even use a compaction with that other demo that I showed you there. And I'm saving a lot of money here. What about the caveman speak? Why does passing the inline object? Now, this is a little bit interesting because this is to show you that you can't really do compaction and get the same answer there. So I'm going to go, okay, speak like a caveman. Why does passing an inline object and error functions or and React child component? Yeah, and then I get the before the normal answer, 600 output tokens, and then I get the actual after caveman speak. But look, I lost a little bit of the understanding for this because this is not as detailed as the actual before I actually went in there with compaction though. So those are the two demos I'm going to do. And then for the time of the demo, you can actually go in there. So that's the URL for the one demo. Let's go back into that other, and you can play around with it there. Let's go into that though. And I'm just going to go into the token flow demo here. And then I'm going to switch these off afterwards to make sure that they don't get abused there. So let's go into here. And those are the two demos. Have a play around with it. And then I'm going to hand it back to my friends at Pact, Sakib, and then I'm going to take your questions.
Rory, that was exhilarating. Thank you so much for that small session. Wow, you nailed it. Appreciate that. I just want to quickly look at if anybody has any questions, right? And yeah, if you guys have any questions, please post them in the Q&A section, which is below the chat, so that I can also show them on the stage. Meanwhile, I'll ask questions. You made my job a bit difficult, Rory, because I had prepared a set of questions that you already answered. So let me just think where to pick from. All right.
I'm very, very interested to know the original questions that you asked, and then I can give you maybe a little bit more insight on each of them.
Let's probably talk about drawing the line on agents, because marketing blurs the line between a chatbot and an agent constantly. So where do you draw it as an engineer?
Okay, an agent has agency. An agency is self-determination. And self-determination is an agent to understand that they need to achieve a certain task. But that task can only be given to them if you understand how to do that. Now, I've got another demo that I'm going to show you here, because agents, when the basic principle behind agents is also a bit lost here. So let's go into, and you can access that, and you can go aka.ms/agent patterns. So what is an agent? So here's my agentic pattern showcase, and you've got your if then else statements here, and your conditional routing and your agent patterns. But this is what I understand as an actual agent, or a supervisor agent. And in it, this says transfer $100 from Mario to Georgios, then convert $50 to euro. It's an agent, but let's actually go there. Tell let's actually go change that. And I'm going to actually put your, instead of from Mario, I'm going to go Kib. Yes, I got your, yeah, that's a Q. Yeah. Georgia can convert that. Now I'm going to execute. Now I've given them agency. I've given them, and this is using LangChain for J, agentic patterns. And you can actually go in, it's also on my GitHub profile. And it's going to use the bank supervisor, the withdrawal agent, the credit agent, the exchange agent. And each one of these, the banking supervisor says, okay, I need to supervise the withdrawal agent, the credit agent, and the exchange agent. Now, when I execute them, I'm giving them agency. I'm telling them what to do and how to do it, though. An agent just isn't an LLM, a large language model, to say, go in and do whatever you want, though. That's madness. It's rather, it sees there, okay, there's no, let's actually, I don't think you had an account balance to start with. Sorry, you're going to have to buy into the bank there. So let's go back into their a supervisor agent, and let's go into the execute patterns. You didn't have any money in my bank. What can I say? So I've given it, and I didn't have agency for you. And then from Mario to Georgia's, so I've got the supervisor agent who is going to now take the withdrawal sub agent, the credit agent, and the exchange agent. And there it is. $100 has been transferred from Mario to Georgios, and $50 has been converted to euros, resulting in 46. And what I did is that I made sure the scope was small. I created the project with my dev container.json, with my with my agent profile. I also used the correct model. This is using GPT-4o, so it's costing me cents per month to actually run that. And I've got everything locked down, running on Azure using the with managed identity. So that's what I consider an agent. It's something that is clearly aligned. You've got a plan, you've created it, you've locked it down, and then it performs a task, an excellently well contextualized task to actually get the job done.
Interesting. Thank you so much for taking us through the demo. We also saw you, like, we just saw caching take a call from 5 cent to under 1, and compaction cut a working context nearly in a half. So those are demos under your control. But let's just talk about real world scenarios. What is the most common way teams waste money, and probably without realizing it?
So I've got, I'm actually running something in the background. I should actually check that it's running here. But sure. This is the token design pattern. If you remember the patterns that I actually showed you, and that's the demo that I just showed you. What I've got here, and you can see here, let's just minimize that, and we minimize that. I've got my Copilot instruction file there that says what you're going to do and how you're going to do it. So I'm setting the context pretty well. And then I've got my agent profile here. Now, very important in my agent profile, I've only got the tools that I need for it to function. Because every time that I send through to an LLM, I'm using a really big model here, but you could actually use a smaller model. I'm going to use the smallest model here, lightweight model here. And I've got Terra also, which is the midweight model. Now I'm going to use my agent profile, the token flow maximize. And I'm going to say, give me some cost saving tips. Now I'm going to call this, and then we're going to see how much that costs me. Because at the end of the day, you don't want to vibe code with Sol without that. And it says, look at the project's Azure cost there. Now, as I'm doing that there, look at that. I've got the context window, and it's going to, once it's finished there, it's going to actually tell me how much I'm going to cost here. And after that, I'm going to show you exactly how to actually reconcile your costs here. Look how fast that is. I've got Luna, which is the cheapest model. No thinking. So the reasoning is off. It's giving me everything that you're going to do there. And then if I was running this in a you can go Chronicle. You can't do Chronicle here because it's not that. But if I was running it in Copilot CLI, I might say, tell me some other cost savings that I myself have violated. So I'm using the right tool for the right job, the right model, just to ask it there. I'm using a agent profile. I've got my Copilot instruction here. This is the demo that I showed you here. I'm not using reasoning. I don't need reasoning right here. I'm using a local model, but I can actually go to Copilot or Cloud at any given time. But I'm really, really cost aware and I'm performance aware of what I actually wanted to do. I'm lowering the tools here. I could actually go in here and I could say, go give me all the tools that you could have. You can see there, I've minimized the tools here. So the JSON to and from it's not going to cost. My actual project is locked down here. So it's about taking a step back and going, yeah, I want to vibe code and everything, but I want to do it correctly and not get a bull shock of $500 million.
Interesting. And on the note of doing it correctly, so let's just talk about agent in the loop, which resends its context on every iteration. So everything that you showed also does compound, right? So you did cover it, in your first demo. So at what point do caching and compaction stop being optimizations? Tell us maybe about that, or and also become the difference between a loop you can afford and one you cannot, maybe.
Okay, so you got it right, but you got it wrong also. So caching and compaction is great though, but you also want to have, with the agent and loop, so this is going to write a story about dragons in Shakespeare style. But what it's going to do, it's going to review it. So the loop workflow, agents iterate until an exit condition is met, perfect for refinement and quality of improvement style. So I'm going to execute that. And what you're going to see here, I'm going to set the expectation in the code that you can only go in and review and improve your story 5 times. And I went, oh, there it is. And the final story that I have actually came through, and I've got my, let's go into my event log here. And you can see there, I've got, okay, what's the reviewer here? Score style, and I've scored it. I say, listen, it's not going to be perfect. It's 80% of the time. You've got an 80% here. I've got my max iterations 5 set there. I've got the agents that are running and 3 agents there, and then stop. So you can compact it. You can go in there and you can say compact though, but sometimes you really need to say, I don't need it perfect. And that's a problem that people are experiencing though, that yeah, caching, you can go in there and we saw caching. Let's go back into what we want to go, token flow here. If you want to play around while we're online here, you can go into, wait, where are we here? We don't want to do that. You want to go into caching here, and you can see there, I've got the cache to generate, and then it's going to do the answer. And yeah, you can run the cache though, but if I run this infinitely, am I doing the right thing? No, I want to be able to loop it and say, review it and score it. And when it's ready, just give me the score and send it back, maximum times of iterations. So you got it right. You want to do caching and compaction, but you also want to have a hard stop when it hits the score that you want to hit.
Interesting. Thank you for showing us how agentic systems can execute multi-step work with little supervision. But tell us also where they still fall down hardest in practice.
I'll probably say that everyone wants to, and you can see here, everyone wants to go in, and this is actually the LangChain for J training that I did here. So if you go into, let's go into here, and LangChain for J, so this is the official training. It's got 400 stars here. And in here, it teaches you about RAG. And what RAG will actually teach you here, and you can see there, what you're going to learn, document processing, creating embeddings. And RAG is pretty, and it's got a nice video, associated video with it there. So what is RAG? And what RAG is going to do is you're going to get a user query. It's going to create an embedding, and it's going to use a vector search, going to bring out the document, and then it's going to give a response. So people say, okay, cool. All of our documents, all of our data, all of the time, go in and return back to the customer every single time. And then the customer is going to go, why is it so slow? And you're going to say, why is it so expensive? When in truth, all you need is a tiny bit. And let's go here. Let's go see if I've got a nice video here. You've got your in-memory store here. So we can actually chunk it. And then you're going to say, here's the full document, split it up. And this is a whole different industry that is going to, that is forming here. And now you've got something smaller. You've got your embedding models here. And then creating your data store, understanding where your data sits. So you only pull out a tiny bit of that. And if you see that, remember the token flow model here, that we can actually go into the demo here, retrieval, run that. How does agentic scope share state between agents? I'm going to pull it out. I'm only going to return the tiny bit of there and then say, and yeah, now that we have it there, and I'm going to have huge projected savings here, 67% instead of just sending the document back to the customer. So that's the ask that I have for you. Think about data. Think about your customers, or what little bit of information. When you do caching, look at the prefix and only send them the tail. It's an entire industry has just created and woken up to us. And then you don't have to have that $500 million bill.
That's interesting. But Rory, as agents can take their own actions, right? We also have to consider authorization, right? Because oftentimes that can be underestimated. So tell us, how should a team decide what an agent is allowed to do, and does a spend cap belong inside that authorization boundary as well? Maybe.
So let me. I've got another demo to show you. Okay, no, this one's running. Let me just close that there. It's still. I've still got an agent running in the background. So that's what you don't want to do. Just have an agent running. I'm probably going to get a bill here of $1,000, and that's really because we have infinite tokens here. What you want to do is well, you want to take a step back and really ask yourself, how much money do I have? Because a lot of what you're asking me assumes that you have infinite amount of tokens, though. And I want to show you here, and I want to let's go into here, and I want to go into here. So if you see, and let's not go into here. Let's go token design patterns. I want to go into let's go open recent, and I want to go more, and I want to go instant model. So in my instant models here. Actually, yeah, instant models here, and I want to go instant models here. In here, I actually have again in the GitHub here, I've got my agents here, and I've got a token cost runner agent. And in it there, I'm going to say, who are you? You're a live token cost runner for instant model sample. You execute the sample's real flows against the deployed boundary model, and you read the actual token usage and live price. So this is an agent that is going to help me save costs. And then I can say to it, okay, so you are, let's go token cost run manual, cost the instant model I have using live Azure pricing. Find the lowest cost for the prompt. Tell me a dad joke with caching the prefix and tail. So this is an agent that helps me with cost. And I should be calling this all the time to make sure that I understand, and your architects and your engineers and your supervisors, to understand the exact nuances around every time you call or use a GitHub Copilot. And you can see that I'm using Luna, and I'm not even using thinking here, so it's the right tool for the job. The second command here. So this is going to go through that. And I don't think I have this running right now, so it's not going to really run. I have to log in to Azure here. But it's going to run through, and if you remember what we did here, this is exactly how I built. And when I went through that, let's go into here. That is the instant models. So let's go into here. And that agent actually built that. So it said, okay, find me the lowest cost here in what area here, and it gave me the Azure results here. And then I went through the caching and then the compaction though. So you really want to build agents to help you lower your cost for agents though. And you can actually have a pyramid of agents all the way up. From right at the top is what you want to achieve, and then you have a foundation underneath there with your dev container, with your Copilot instructions, with your agent models, using compaction, using compression, and it's an industry there. So it's not a simple answer there. It's really, it depends on what your usage is.
Yeah. That's excellent. Thank you so much for explaining that. Rory, I do have a couple of more questions, but there is somebody who asked us a question from the audience, and I want to show it on the stage, and then I can just come back and ask that question to you.
Sure.
All right, here we go. We have Praveen Kaushik asking the question about the best balance of harness and loops, which doesn't cost much tokens.
See, it's not really costing that you have to worry about. So the cost is great, but what are you trying to achieve? And if you look at the harness that we have here, let's go into. Actually, no, I'm gonna bring on my LinkedIn profile because I actually posted this recently. So let's go into Rory in LinkedIn. It was a really great post that I did, and I got a lot of feedback from this here. So in my LinkedIn profile, I actually said, sometimes you don't want to use our models. Sometimes you want to use models that are local. Sometimes you want to use models that this is the Microsoft Agent Framework Coding Connector Agent Connectors. So we've got a really great framework called Microsoft Agent Framework. If you remember a semantic kernel, if you remember Microsoft agent libraries, we've actually got that now. But then we use the routing task and we say, maybe you want to use GitHub Copilot. Guess what? If you have a Copilot license, did you know that you can actually use it as an agent? Because you have spend there. So you can also use Claude Code for routing your task there. And we've just released that though. So the best harness that you could use to save costs is GitHub Copilot because it is an agent. So you could actually say, wait a second, I've got my $40 or however many, I've got my base spend there. And maybe I just want to use GitHub Copilot. And we have the Copilot SDK and we have the Microsoft Agent Framework. And you can just say, route it to GitHub Copilot based on the usage. And I showed you routing earlier. And or route it to Claude Code or another agent or a local agent that you have though. But you have to say, what is the best tool for the job there? And you want to use routing, and we showed you there, you can use routing with the lowest model, the simplest model. I've run everything now off Luna, which is pretty cheap. So that it really depends on what you're trying to achieve. Really good question. Thank you.
Perfect. I'll mark it as answered. Guys, if you have any questions, please post them in the question and answer section. Thank you, Praveen, for asking that question. Rory, I quickly want to mention talk about the trend that had started some time ago about token maxing, right? And we actually published a special issue on that, like why judgment and not token maxing creates the value. It was Amazon and Meta both built internal leaderboards ranking engineers by how many tokens they burned, and they tore them down within a quarter after engineers started padding their usage to climb the board. So yeah, that's the industry. Even that's how industry I think coined that term around token maxing. Please share your thoughts around that if you can.
So when I was a cloud advocate, I would sit with the CTOs of large banks. We're talking people who have a GDP larger than some countries. Yeah. And I would sit with them and I'd say, what's your biggest worry? And they said, I want to know how much I'm going to spend on cloud. Like I've previously, I could forecast 4 years, I could buy the servers, and then I'll depreciate the costs. And now I've got another worry. How much am I going to save on cloud? Because instead of going and spending more, you're going to say to yourself, like I showed you today, start at the foundation, use the smallest model, use compaction, compression, and design patterns, routing, and then slowly build yourself up. And this is one of the reasons why I noticed and I did this presentation, because I would hear from developers around the world, I ran out of tokens. I go, what you doing? Mm-hmm. And they go, I just tell them I use the top model, I send it away, and then I run out of tokens. I go, do you need the best model for the job? And then they would all come back to me, I don't know. I said, have you used / Chronicle to ask it to analyze your usage, or have you set a limit? What? Yeah, no. I'm just going there and I'm I'm driving. Where's that animation there? Let's go. Let's find that animation. Sorry, I'm flashing here. That. I'm just going there and I'm vibe coding until I don't know what's going. I get the ball run out of tokens. I don't put in a Copilot instruction. I don't have an agent profile. So we really want to take a step back and say, just like cloud, take a step back, create the foundation. Don't just go berserk with that. So yeah, definitely create the foundation, use Luna, which is a small model, set up your foundation. And then like cloud, start looking at what's the minimum and then cost save, not maximum, and then, depreciate your hardware.
Interesting. Roy, that's a great presentation, by the way. Are you going to share that with the audience as well?
I can send it in PowerPoint. One of the things that I learned at Microsoft is that not everyone has an M365 license. Not everyone has that though. So I will send it to you. Let's go here. Let's go far. And watch how easy this is. I'm going to go export. I'll do this live on a create PDF here. And I'm going to now go, okay, cool. Options. We want to do that. I'm going to make sure that is there. I'm going to pop it into my drive C, into my temp folder here. So it's not... and then publish. And now I've got a PDF version of that. And a lot of this was created using GitHub Copilot and also a lot of these animations with also M365. So I've got the presentation. I'm not too sure where I can kind of share this with you, but if you tell me, I'm gonna drop it with you.
Yeah, I can take them via email from you, and then probably next week, I'll try to publish a deep dive based on the presentation you gave with the video and share it with our audience that joined today.
Okay. I've got a better bit also. I can just pop a link in there because I have, I'm going to just put it into a share folder. None of this is sensitive information, so I don't have to worry about that because this is everything here. So let's go find it here, date modified, and I'll pop it into the chat here and send it through to your audience today.
Perfect. Thank you so much. That's really helpful. While you're doing that, I just want to quickly mention that one of our contributors for the token maxing issue we did, he mentioned that token use is basically a low-level metric like CPU utilization, and the honest unit is cost per bottleneck relieved. What do you think about that?
Sorry, I missed you. Cost per. I just popped the link in there.
Yes.
Cost per.
So one of our contributors for the previous issue, he put it this way: token use is a low-level metric like CPU utilization, and the honest unit is cost per bottleneck relieved.
Yeah, the cost per bottleneck relieved.
Yeah,
I agree with that. So what happened to me is I burnt 51 million tokens recently, and in that I used the wrong model for a specific purpose. I was trying to show an accessibility fix. So I also with the GitHub Copilot app team. So if you go into here and you go Copilot app, I helped announce this and I did the actual thing. So this is the GitHub Copilot app. I would love to actually show you this quickly. And in there, I can just start those sessions. Then I can go, okay, actions, new individual sessions, go in there, and then I can go in, and this is the GitHub Copilot app. You saw how quickly I did that. These are just things that, and then in there, it was a issue that I set there, but I'd set later, I'd set one of the issues there to go in and let's go into merge here. So I wanted to go conflicts here, and I'd say resolve conflicts. So I would go resolve the conflicts, merge blocked, and I used a very small model. I used Luna, and it came back to say, you've just spent 51 million tokens. And I went, why? Because the model couldn't solve the problem. And I hadn't set a loop there to say, please, after a while, stop. So the live on air, I had to say to them, please use the right model that you want for the job though. Let's see, okay, we're using Sol, so we're using the right model for that job though. So yeah, I agree with you, but it also depends on what model you're going to do to resolve the bottleneck.
Interesting. Tell us maybe now, for an engineer early in their career, right? What skill is worth far more today than it was maybe 2 years ago, and what is probably worth less?
Programming skills are worth more. So anyone tells you you don't need a program is wrong, because that's just going to cost you money. Hey, you don't know how to program. You use the wrong thing there. You push something to production. You're either going to lose all of your money, or you're not going to have a system there. So I would still say the best skills right now to understand basic programming principles there. And we have the largest a place in the world called Microsoft Learn. Microsoft Learn. Let's go into there. Now, Microsoft Learn here, you've got Learn training here. I have published, I think, about 7 of these modules here, and you can discover your path. You can become a programmer. You can browse the training. You can build your careers here. So definitely go in there, learn about cloud. Cloud is a given. You have to understand about cloud. You have to understand about AI, but you also have to understand how the AI agent is going to call the underlying tools, the Python tools, the Java tools, and even more so now. So definitely go in there, use some of our certifications. AZ900 is the go-to for Azure. We also have the AI certifications. I would start with an AI certification. I think that's really important here. So let's go career paths here, AI engineer here. You also get training for engineers here. What is an AI engineer? And let's go into here, develop generic apps in Azure. Definitely go there, self-learn training here. A lot of them have certifications or link to certifications. So yeah, definitely go into the Microsoft Learn, learn the programming concepts, learn the cloud concepts, learn the AI concepts. It's an incredible time to be a programmer nowadays.
Awesome. That's a very edifying advice. Thank you so much, Rory. Rory, I think you might have something in chat. I think, yeah, you did share that link. Thank you so much. I may ask 1 or 2 more questions if that's allowed. If your time permits.
That's cool. Yeah. Go right in. I'm having a ball of a time.
Yeah, it's one of the best times for me as well. Thank you so much. I've learned so much today. Tell us maybe about, because teams are shipping large volumes of AI written code that sometimes other people don't understand, like reviewers. So how do we keep that from becoming the next legacy code crisis? Because we already have one problem that we wanted to solve, and we might be creating another one.
Okay, so there are people and there are things to help you. And if you go into Gartner hype cycle, right at the bottom of the Gartner hype cycle, let's go looking for images here. I want to show you something here. So let's go 2025. Let's see here. So right at the bottom of the hype cycle here, for published here, let's see here. Right at the bottom is something called cybernetic teammates. Sounds interesting for that. So what is a cybernetic teammate? I already showed you one of them. That's the little agent profile here. This is a friend that I can use at any given time that my management or your leaders or your mentors can create, that can help you. You may not work in an office that has the same kind of ease of get up, walk to someone and say, listen, I'm spending too much tokens, help me out. Your leaders should go in and create the agent profiles. You've got agent profile runner and then analyzer here that will go in and say, listen, I'm not around to help you out, but I've created a nice agent profile that has everything that I need though. I've just got pinged by my GitHub Copilot, just finished the merge there, merged and pushed there. And so I just did 4 issues right now with the GitHub Copilot as we were speaking here. And now I can actually go here and I can go, okay, how much did I spend there? Let's hope that I didn't spend too much on the Chronicle. Let's see how much we spend there. And I can go cost tips here. But don't worry, I do have a Chronicle cash token canvas that I created. So I can go here and I can go, what is the canvas? Okay. That is, that's a lot of tokens. And you can see, yeah, this is actually built from Chronicle. And I'm going to refresh it here, 72 million tokens here. And how much did I spend today? Let's go. Okay, no, it hasn't updated. Oh my gosh. Okay, don't tell my management. Okay, I may have spent a little bit too much here, but it's busy refreshing, and now you can monitor it. So that was as simple as, if you remember, just going in and Chronicle, creating a canvas here, my daily token pulse here. I've got all the tools that you need to actually go and monitor. There's nothing stopping me from saying, step back. I'm not doing the right thing. I'm going to go do it better here. Let's go 7 days and we can refresh it there. And let's see how many tokens we spent today. It's 7 days. No, we want to go 36 there. Let's just wait for it to finish here. So we've got Chronicle, we've got limits, we've got canvases. We have everything that we need. We've got the right tools. We've got the right agents. We've got agent profiles. It's an industry. There's a whole industry out there just for token efficiency. It's going to be like what we saw there. Remember cloud engineers? Remember a long time ago, where cloud engineers started? They just created scripts, really good scripts. And then AWS was created, Azure was created, 46 million. Okay, so I've saved in quite a lot there. And how many did we do today? 23 tokens. Okay, didn't actually pick it up though, because I hadn't actually used the coding agent though. But okay, so I can tell my management I'm good. I'm good. I didn't really spend too much. Don't get me into trouble.
Yeah. All right. Thank you so much. I think this is where also a lot of startups are coming up around FinOps, cost optimization for AI workloads. And even the new careers are starting out as FinOps engineers, FinOps practitioners, where companies are bringing people who can help with performance engineering as well as optimizing the cost of AI workloads. It's good. You put it up.
This is a whole industry. Token efficiency is a whole. I've seen it happen with cloud, cost savings. This is what I built myself for 5 years, and then AI came about, and I started moving over to there, and I thought the exact same thing is happening. People are spending too much. I've sat with CTOs. Rather than spend more, spend less. Know what you're doing, and also have fun. I created this dashboard. Have fun while doing it, and don't just pretend it doesn't exist. Rather take a step back and go, I'm going to try Luna as a model. It's very cheap. I'm going to switch off reasoning. If it doesn't match my needs, maybe I need a router with a design pattern, and then go start small, build up.
Interesting. Rory, looking a year or two out, what will be obvious in hindsight that most teams are not acting on yet?
If most teams survive the token apocalypse, I think the Token Economics Foundation is going to help a lot. We're one of the, and if you want to go into here, you can go into, let's go into there, and let's go into AI agents, and we can go Token Economics Foundation, live on air. I'm typing foundation. I think this is my most exciting Token Economics Foundation. Let's there we go. And intend to launch that. I think this, once it's launched, and I'll pop it in there into the channel there. Once this is launched, I think it'll change a lot though, because this is like the Linux Foundation. They're going to put in cost mechanisms. They're going to save the consumer here. AI cost management. They're going to say, okay, cool. If you're going to have an AI model, you need a dashboard. You need like a canvas, like I showed you there. You need to tell them and teach them, and you need to have certain standards in place to actually help the consumer.
Yeah. And how might people get involved in this based on your experience?
The easiest way to get started really is to play. We're developers, or if you're not a developer, you start up GitHub Copilot here. So let's go here, and you go File, add a new window here. You start. Let's just go into here, and I'm going to open up File. Open folder here. I'm going to just create a project. I'm going to go in there. I'm going to go dev, and then I'm going to go here, and let's make that a little bit bigger. And I'm going to go new folder, demo packed. I don't know if I spelled that right. Demo packed. Yeah, select the folder. And then I'm going to go, okay, I'm going to choose the lowest model that I've got there, Luna and none here. And I'm going to go create a Copilot instruction file for, no, actually, I'm going to go for a dad joke generator along with a agent profile. I'm going to say, rather there, build a dad joke generator. And then I'm going to make sure that I say, and create a Copilot instruction file and an agent profile. Now I've got the lowest model that you can actually choose of any value. You can even do a local model there. And then it's going to create one for me, and I'm going to learn. I'm going to learn how to do this properly. It's going to make sure that it doesn't actually set me in the wrong state. I'm going to create the baseline there. You saw how easy it was to do that. I'm not even going to really be charged for this. It's going to be so small what I want to be charged here. If you remember Luna here, I can actually see there, okay, lightweight model, cost per million tokens, default 100. Compare that to Claude Opus 4.8, you've got 500 and output 2,500. So I know what I'm doing. I'm not terrorized. I'm not going to really do anything wrong here. And then, yeah, it's busy creating it there. It's serving the generation there. And then I've got my GitHub here. I've got my Copilot instructions. I've got my agent profile. And if I wanted to there, I can actually go into my dad joke generator. I feel safe. I can go tell my, and there we go. There's my dad joke generator. That took what, 2 seconds to do? Give me another there. And then it's going to actually run through that. And there we go. Little grown, what do you call a sleeping bull? A bulldozer. Simple, safe, simple, safe. Using GitHub Copilot. And then if I wanted to, after there, the same license I want to do, Copilot SDK, I can go, okay, cool. Now, go generate a few dad jokes for me.
Interesting. I know you like testing agents with dad jokes.
I'm full of adrenaline I'm so excited to speak to the prompt, though, that I needed an AI agent to actually go do that. Give me another. How did the computer go to the doctor? Why did the computer go to the doctor? It had a virus. It's clean. It's nice. It's gentle though. But also, I do have, and I've got a whole nother presentation on burnout with AI, because a lot of times your brain gets all fuzzy. Let's show you here. Burnout. Let's go here. Burnout may. We want to go there. Burnout may there. The biggest problem that we're experiencing right now is no, not that one. Let's go here. That is something I want to leave you with also. Know what you're doing, and don't end each day exhausted, not from the work itself, but from managing of the work. Be kind to yourself. Understand what you're doing. Set the foundation. Let the adrenaline flow. Do the vibe coding, but do it in the correct way. And then use Luna. And yeah, thank you so much for hosting me today.
Awesome. Well, this brings us to the end of our time, Rory. Thank you so much. This is exactly the kind of grounded conversations we hope for. So we'll publish a newsletter issue based on our conversation in coming weeks. So I hope people listening to us today will subscribe to Deep Engineering. And yes, thank you so much for joining us. So see you at the next Deep Engineering Live. Appreciate it.
Cheers, everyone.
All right. Thank you.